Hello, my name is Steve Samuel from Design Visionaries, and today I'd like to share with you some geometry that we've created, that we designed and envisioned, and then we actually created hardware. So what I have here is a pontoon boat, and it's a forward-facing rower. In other words, you use these oars and you row this boat just like you normally would, only you get to face forward instead of facing rearward, the way you'd always do on a regular rowboat. So this rowboat, we wanted to put it together and not really have to spend too much and work too hard. So we opted for a PVC pipe frame that holds these two robots together. Robots? Pontoons. I don't know where robots came from. Got robots on the brain, I guess. These pontoons were made of thin plywood, very thin plywood, 0.125, a 1/8 plywood, and there was some structure to it in certain areas. And then we fiberglassed the whole thing. We put fiberglass a cloth on it, and we used the polyester resin, and then we did a gel coat. Took a while. And then we cut in these ports that we purchased, and that's just to make sure that if it does leak at all, we can evacuate that. And we've got these kind of crossbars. We've got an adjustable footrest that we made out of 2x2s, and this little seat that we made out of a piece of plywood and some other lumber. And so the cool thing is this little gear system, that's the heart of the entire invention here. The gear system reverses the direction on the oars, which you'll see in just a moment. And these gears were printed out of carbon fiber nylon, so they were 3D printed. We didn't know if it was going to work. We didn't have any indication. I mean, we could have done this whole incredible finite element analysis, etc., but in the end analysis, we wouldn't know. We didn't know what the exact properties of this substance we were using. So we just tried it. And spoiler alert, it worked. So now I'm going to take you through a quick calculation of the displacement. So I'm going to say Control B and select everything and hold my finger on the Shift key and deselect just that little side hull. Okay. If I say Control H, you can see that this is just made out of thin plywood. There's a plywood back here and thin plywood, but what I really need to know is what's the water inside. If I can calculate the weight of the water inside, then of course that's how much it can hold. And so the very first thing I'm going to do is make a water line. I'm going to go up from here, and I'm going to arbitrarily say 8 inches. So let's say the pontoon is in the water by 8 inches. And so now we have a datum plane there. And now we can determine what the weight of the water would be. The easiest way I know how to do that is to extract the internal surfaces and make a solid, and then clip it with the datum plane and weigh it. So in order to do that, I'm going to say extract geometry. Extract geometry. I want region of faces, and I want to select an internal surface as a seed face. The boundary faces are simply here. And I want to go into settings and make sure this is associative. And I want to fix a current timestamp. And I also want to hide the original. So I say OK. And what I get is a model of all the interior surfaces all sewn together. Then I want it to be a solid, so I'm going to go to Surface, More, Bounded Plane, bounded plane, select this edge, say OK. go to the sew command. So I'm going to put this together with this, and I'm going to click on this show result to make sure it says solid body created. That's good. Good. Then I'm going to go back to home and use the trim function, trim body. There's the body. There's the datum plane. Switch the polarity. Okay. Okay, so what this little shape represents is the internal volume up to the water level, and we have to assume that it's displacing water in about that size plus a little bit more. So if we put the mass properties of water onto the solid and weigh it, we'll know exactly how many pounds this one pontoon can hold. So we'll do tools, assign materials. We're going to look for water. Water, as we all know, has three phases. So we'll certainly give it the liquid phase as opposed to the solid, because the solid is less dense, which is kind of baffling. Water is so special the way it does that. This took a long time to come back because my libraries are not local. So here's water. Okay. And so there's the piece, and say OK. And then go to the analysis tool, measure. What we're going to do is measure body. I'm going to take off all these other things. Measure body. And I want to make sure that this says object. I'm going to select the object. Whoops, that's not the object I wanted. Let's remove that object. Not working, hold on. Let's do measure again. We've got the properties correct, and we're going to do solid body this time. And everything is as they were then, so I'm going to click on this and say OK. Now, since my screen is so big, the actual dialog came up in another place. But hold on. All right, one more time. So we're going to leave that on. Select an object. There it goes. So it says the mass is 221 pounds. 221 pounds, which means that with the two holes together, we have 440 some odd pounds that we can lift just with this level of immersion. That's 221 and a third pound. Okay, so that's really a good method. I use it all the time to calculate the volumes of very complex surfaces. And now getting back everything. Like that. Okay, so I'm going to say File, Save All. And I'll meet you in the next portion of the video. Thank you. It was a beautiful day in San Jose, California, and we made our way to Calero Lake Reservoir, where we had a podium set up, and I was able to speak to 25 friends that came to see the launch, and it was wonderful. And I talked about the importance of community and family and creativity, and my brother had on his wonderful hat, and we had some local politicians come and say very positive things, and it's a very close-knit society we live in. And then we had friends help launch the boat. It was terrific. I jumped on and I was so excited. And to my delight and surprise, the oars worked so well. And as I pulled them, they pushed the boat forward, and I didn't have in my excitement, I didn't have a personal flotation device on, so the ranger came by and yelled at me. But as you can see, it was a beautiful day in San Jose, and everybody was happy. We ate some nice barbecue food and really enjoyed each other. but the key thing is the bores worked perfectly, and it was a big success.